IM2 classes. Today we're talking about right triangle trigonometry. Our textbook likes to split into two lessons, starting with the tangent ratio and then the sine cosine ratios. We're going to do it all at once because that's kind of dumb. So let's get right into it and talk about what these ratios are. So the ratios are side lengths on right triangles. You're comparing side lengths with angles of right triangles. We have this mnemonic here to help us remember what the ratios are. SOHCAHTOA. You may have heard that before. We're going to hear this term a lot in the next couple of days, but SOHCAHTOA, what SOHCAHTOA stands for is the S is sine, then opposite hypotenuse, then cosine, adjacent hypotenuse, and then tangent, opposite, and adjacent. How this works is we use these to set up these ratios, and it's based off an angle. So first thing you want to do when using these ratios is you're going to be going with respect to one angle. So I'm going to label the angle here. In our problems, the angle is going to be given to us. We'll know which one we're going to be using. So this one, we're going to use this angle X here. I'm going to put a right angle box right there just to help us out. First thing I'm going to do is label the sides as hypotenuse, opposite, and adjacent. I'm always going to start with the hypotenuse because that's the easy one. The hypotenuse is just the longest side. It's always across from the right angle. So this is the hypotenuse. Now the opposite and adjacent are relative to your angle. So what I like to do with that angle that's given to us, I draw an eyeball on that angle, and the eyeball, no, that's not what I wanted. The eyeball is looking at the opposite side. So whatever side the eyeball is looking at, hey, doesn't it want me to draw an eyeball? What the heck? There's an eyeball. All right, the hypotenuse and then the eyeball is looking at the opposite side. And then down here, the side next to the eyeball or next to the angle is the adjacent side. Adjacent literally means next to, right? And so we do need to differentiate because the hypotenuse and adjacent are both next to the angle. The hypotenuse is always going to be the longest one. And so how this works is when we set up these ratios, so the sine of X is going to be the opposite side length over the adjacent side length, right? The cosine of X is the adjacent, should put in that X there, is the adjacent side length over the hypotenuse. And then the tangent of X is going to be the opposite over the adjacent. And so I didn't need to write out all of adjacent, but that's okay. This mnemonic SOHCAHTOA helps us remember that sine is opposite over adjacent. No, opposite over hypotenuse. What am I thinking? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Sometimes, actually all the time, I prefer to write it out like this. SOHCAHTOA. So you can do what you want. All right. Let's look at an example of actually doing these ratios. So we want to remember, SOHCAHTOA. We are going from angle X. So I'm going to label angle X. I'm going to put my eyeball in angle X. The eyeball is looking at the opposite sides. This is the 36 is opposite. The 45 is the longest. That's the hypotenuse. And this side left over is the adjacent. All right. Sine is the opposite over the hypotenuse. So that is equal to the 36 over 45. And if you want to get really fancy, we can reduce that. You can divide both the top and bottom by 9. So that's going to be 4/5. The cosine is adjacent over hypotenuse. Okay, whatever. So that's going to be 30, no, 27/45. And that comes out to 3/5. And then the tangent is the opposite over the adjacent. And that comes out to 36/27. And that's 4/3. And there you go. So setting up the ratios, that's as easy as it is. What we're gonna, before we get there, real quick, you want to check your calculator. We'll do this in class. You want to make sure your calculator is in degrees. Everything is a little bit different. You're not gonna be able to see it on that little screen. Whatever. Your calculators will be like a little D there, or it'll say DEG like it does on my calculator. You need to make sure it says degrees if you need help with that. Either look up how to do it online, or I can help you in class. But you want to make sure your calculator is in degrees. So if we're going to put in sine of 32, that is 0.52. We don't typically need to go this far, but I'm going to do that anyway, 0.5299. Try that on your calculator. If you're not getting 0.5299, you're not in degrees. Like tangent of 41. Tangent of 41 is 0.869. Make sure you're getting those values, because if you're not in degrees. We want to make sure you're in degrees. All right. If you need help with that, I can help you out in class. Here we're going to set these up. You can pause this and take a video, but a little flow chart if you want to find which trig function to use. I think just thinking about SOHCAHTOA is good enough. So let's get into it. We need to find this missing side length, x. We're going to use those trig ratios, those trig functions to do that. So what you want to do, you want to label the sides opposite, adjacent, and hypotenuse based on the given angle. So our angle here is the one that we know the measure of. So it's this 50-degree angle. I'm going to draw my eyeball in here. All right. The eyeball is looking at the opposite side. The side 10 is going to be the hypotenuse. And then that means this side here is the adjacent. All right. So now next we need to choose the trig function that uses the given sides. So what we want to do, we're going to look at the SOHCAHTOA. All right. We know the hypotenuse. We are looking for the opposite. Which one of these uses opposite and hypotenuse? That's going to be sine here. All right. So we know the hypotenuse, looking for the opposite. You just got to pick this out. All right. So I'm going to set up my trig function. So it's going to be sine of 50 is equal to the opposite over hypotenuse. And then this is real simple to solve this. To solve for x, all you need to do is multiply both sides by 10 to get rid of the 10 on the bottom. So times 10 divided by 10 cancels out. And you get 10 times the sine of 50. Use a calculator to work that out. 10 times the sine of 50 is 7.66. That's it. So the equations are real simple to solve for. It's just a matter of making sure you pick the right one. So let's do another example. All right. So I'm going to write my SOHCAHTOA. I'm going to start off by labeling the sides. So I'm using this 20-degree angle here. What in the world? Draw my eyeball. The eyeball is looking at the opposite side. The longest side here, across from the right angle, is the hypotenuse. And that means this side left over next to the angle is the adjacent. All right. So we know the hypotenuse, right? We know it's 15. We are looking for the adjacent side. So which one of these uses adjacent and hypotenuse? So opposite hypotenuse, adjacent hypotenuse. So we're going to use cosine, uses the adjacent and hypotenuse. So it's going to be cosine of 20 is equal to the adjacent, which is x over the hypotenuse of 15. And then real quick to solve for x, I'm going to multiply both sides by 15. Put that in parentheses. Doesn't need to be, but I like putting it in parentheses. 15 times the cosine of 20 comes out to 14.095, and that rounds to 14.1. 14.1. I'm going to fix that. All right. We are going to skip ahead to this. So here, yeah, we'll do this one. So same thing, label the sides. So here's my eyeball. Looking at the opposite side, the longest side down here is the hypotenuse, and then this is the adjacent. So SOHCAHTOA, I'm going to write it again up here just because that's the way I like to do it. Think about what side length do you know and what side length are you trying to find? So the side length we know is the opposite. We are trying to find the hypotenuse. So which one of these is opposite and hypotenuse? That's sine again. So you're going to do sine of 31 is equal to the opposite 5 over the hypotenuse x. Notice this one's a little bit different. I put an h instead of an x. Let me fix that. On the other ones, the x was on the top, made it a little bit easier to solve. You just had to multiply by the bottom. You can do that. This is going to do 2 steps. You can multiply both sides. Here, we'll do the whole thing here. So multiply both sides by x to get the x out of the bottom. Separation because it's more than one step here. So it's x times the sine of 31 is equal to 5. And then the next step is to divide by the sine of 31. So it just takes an extra step. Not much. So these cancel out. So you get x is equal to 5 divided by the sine of 31. That's 9.71. All right. Let's do one more example. Yeah, this one. So first I'm going to, label the side lengths. Okay, come on, there we go. All right. The eyeball is looking at the opposite side. Maybe if I make a square eyeball. No, see, it doesn't like when I do that. I don't know. It keeps doing whatever. It's okay. This side, this should have a right angle mark. This side here is the hypotenuse, and then this is the adjacent. So with the SOHCAHTOA, what side length do you know and what are you trying to find? So we know the opposite side. We are trying to find the adjacent. So opposite and adjacent, that is tangent, TOA. So let's set this up. So tangent of 17 is equal to the opposite 22 over the adjacent x. And so here, if you notice, and this will work out the same way every time, when it's all said and done, just the x and the sine are just ending up switching spots here, right? And so that's what we're going to do. Instead of multiplying by x and then dividing by 17, I'm just going to take a shortcut here, all right? The 17, the tangent of 17 and the x, these guys are just going to switch spots. right? And that's going to make it real easy to solve. I wish this board, this PowerPoint would stop doing that. But yeah, so I'm going to just have these guys switch spots because that's essentially what happens every time you solve. So it's going to be x is equal to 22 divided by the tangent of 17. That's the shortcut to solving these. Just switch the x and the trig function when the x is on the bottom, the ratio. So 22 divided by tangent of 17, you get 71.95. Yeah, okay. 17.96, 71.96. And that will do it for us. Next time, we are going to use the trig ratios to find missing angles. Fun stuff. So, more Sokotoa next time. See you.